Hi everyone, welcome to this new webinar. I'm Fanny, your host on this session. Today, we will show you how to install a software development kit, also called SDK. Okay, let's start with some practical information. So, the webinar will last around 45 minutes and will be concluded with a Q&A time. So, if you want to ask questions during the presentation, please feel free to ask them by using the question tool in the interface. And finally, a recording will be available on our website and on our YouTube channel after the webinar. In today's sessions, the speakers will show you with two quick demos how to install our BLE and Wirepas microservices and how to use them to collect data. So we will start this session with a short presentation of the company for those who do not know us. Today's webinar will be presented by Matthew and Stefan, software engineer at ELA Innovation. Matthew, I leave you the floor to present our company.
Hi, this is Matthew from ELA Innovation, and today I will speak about the company to begin this presentation. So, ELA was created in year 2000, 21 years already, and now we are 40 people in this company. And we are in 4 different departments. There are the production part to deliver all the devices, the business and marketing part for all this communication, sales, and social media on the devices, the R&D team, and then the support. Each year, ELA reinvests 40% of everything in the R&D. We deployed for the moment more than 6,000 devices, units through the world. And during the 6 years, the growth was 270%. Our business are reparted in 4 different thematic: transport and telematic, health, industry 4.0, construction and smart building. And then for the next, Stefan will present you what is the ELA SDK.
Hello, everyone. So I'll do just a very short presentation of the ELA SDK that we already presented on the last webinar. So I'll just go through the graph. So it's a very simplified picture of a global solution that could use our SDK. So you can see on the left, you have the connected devices that we want to connect to, scan, and talk to. And on the right, you can see the business logic that you might want to implement in your solution. So our SDK here is in the middle and is used to bridge the gap between those 2 parts and make it as easy as possible to scan, detect, and send command to connected devices. So the main point is you have to look for is that SDK is comprised of a microservice, 2 microservices actually, Bluetooth microservice and Wirepas microservice. And you can deploy a server and you can create a client that will call the server. And this is what we're going to show you in the next 2 demos. And Mathieu will start the Bluetooth microservice. Just so you know, our microservices are coded with the gRPC framework, Google Remote Procedure Call. It's a very good framework, high performance, multi-platform, and very reliable. So this is what we chose to use. And one of the main advantages is that you can code the client in any language that you wish for. So Mathieu will show you a client coded in Python, and I will show you a client coded in C#. So you can do yours with a lot of different languages.
Okay, so before starting the presentation, I will present you the Bluetooth microservice, the server side, how to deploy it, and the client side using Python to implement a client. So for technical reason, we record a little video and that we share, and I will explain you what I do. Okay, so before starting, we go to the ELA Innovation website. This is the starting point for this demonstration, and we go to software and SDK. So by navigating, we reach the page, and we go in the section SDK and software. More, click on the More button to go further, and then you will have all the information around this SDK, sample code and SDK. For the server side, I will download the installer, Windows installer, and I download it. But before installing, I go to GitHub. ELA Innovation is our profile on GitHub, so you can find us directly and navigate to get the main repository. Okay, so in this main repository, you will find lots of samples of code for different technology, like Bluetooth and Wirepas for different platform and OS, Android, Unix, Windows. All is in ELA sample pinned here. But if you go to ELA microservice, you will see all the information relative to the microservice, what they are, the different modules like this, the Bluetooth base module, the ELA Wirepas module, and the ELA authentication, which is a part of the deployment. And this is the dependency for the two services. If you go down in the page, you will find the link for the two samples. And these samples are very important because this is our client side. So you will find C# repository and Python repository. Today, of course, I talk about Python repository for this. So if I click here, I am on the main page of the Python client sample, where you can find all the relative information, how to install gRPC, or how to generate gRPC from Poto, and the main code. And then I install my microservice using the Windows installer. So this is quite easy. I select the language. I follow each step of the wizard. I accept this agreement, click on next. If the microservice is already installed, this installer stop it, reinstall or update the microservice, and put it directly in the Windows service file system. Okay, so wait a little seconds, and next we can click on the Finish button. Okay, this is good. So if we click on the taskbar and have a look on Task Manager, if we go to the Services tab, you will see the ELA microservice. So if I put search ELA, there is two services interesting, ELA authentication and ELA Bluetooth service. Here I stop it and restart it in this order. First ELA authentication and second ELA Bluetooth Win service, because the first one is a dependency of the second one to release the authentication and connect to the module. And I will explain how to do it. Okay, then I open my folder. I try to clone this repository, so the Python sample, but I get this link to clone it. I go back in my folder. I open my Bash terminal, but I can do it with GitHub Desktop and start my Git clone. Okay, like this. I passed the link, and here we are. Perfect. So if we navigate in this folder, you will see there is the sources for C#, the gRPC project, and the Nugget project, and the Python, which is a Python client implementation, as I said. And for this presentation, I will use Visual Studio Code. Okay, so I start this tool and open my Python folder. Okay, so I navigate and I try to find my main application. So if this is the first time like this, you will see some message to install your plugin and everything you need to fulfill and to have some tools to help you. Okay. So here we are. I'll close the notification and I can open my terminal, my PowerShell terminal, to add the dependency, which are explained on the main repository. Like this, I go to the Python README And if the dependencies are not installed, I can copy this link to install gRPC-IO and gRPC-IO tools, copy the line and put it on enter, and PowerShell will do the installation. On my side, this is already installed, but just to have a look, you can do it on yourself. This is not a problem. Okay, so here we are. This is my main application and my main program. And this is ELA BLE Wirepas client P. And I have my main function, login, logout, and the other one. First, the login. This is interesting because for here, I need to log to the module with an authentication request. And I use the credential provided for customer, these two, the login and the password, to allow you to connect to the Bluetooth module and use the main functionalities. Okay, so when I use this, I have this function to create a request, an authentication request, where I define the session ID and the request ID. So the code do it by itself, and you have just to start the program to do it. And the most important is the session ID. This is the result for an authentication request like this. You set the session ID to get the validate key to use the functionality of the module. Everything is described on the GitHub, but this is very, very important to see this, because by using this session ID stored in this object, I will use it for every connection and every function to allow me to use the functionality. Okay, so this is the connection hostname and port. The port is 50,051. This is for the Bluetooth module, and the local host is for the service I install. Okay, so I'll try to connect to my module deployed on my laptop, and then between login and logout, I will have this function which work and get the scanning and the Bluetooth information for me. So start scanner, I start the Bluetooth listening, I sleep 5 seconds to wait, and I will get the data. I enter the Python command to launch my script or run my program, and this is directly the ELA BLE Wirepas client sample. I will enter in my main app and get my data scan in Bluetooth. So as you see, there is my session ID, which will I use, and I have all the data scan in my JSON format. Okay, so if we have a look on the data directly, I will see different data for each Bluetooth scan, the timestamp of the data, the MAC address of the device, the local name of the device, the RSSI value, and some additional data, which are the service data. Everything is contained directly in the payload, and in this payload, you will have information. In additional information, you have this JSON object, which is an interoperable object where I interpret ELA data, like temperature, like this. The format is the T. And if I have a look on another format, this is a magnetic device from ELA, where I have the counter information and the level information. Okay, so like this, I have all my data available. Just if we go further in the login to understand, I will go back in the login function and I will change the credential by one credential. Okay, so just there, I change login, set wrong login, and for the certificate or password, the wrong password. And then you will see that I cannot connect to the module and cannot use this function. So with this credential provided for you, you can directly use and manage all the functions. So if I go back in my main program again, of course, I call the login function, but it won't work. You will see that the API don't provide you the information. Okay, so this session ID is already the same, but there won't be any session ID. And when I use this request, if we just have a look on the request like this function, you will see that if I search the function, this function is used in every call of the API. Okay, so the start data flow, the logout function to release the session ID, the scanning function, and the get data device. So with the wrong authentication like this, I will run the program again. So I will enter the command again. And if you have a look there, this is an invalid credential. So it means that I cannot get access to the module. The session ID is invalid, and so you need to authenticate to do the job, okay? So this is quite easy, and we try to get quite easy. If I go back and change with the good one and the customer identification of the customer login, like this, everything will work again. I start the script, I get the session ID, a good one, is one new for every connection, and then I got my different objects scanned. Okay, so this is important between login and logout. When you logged, every function will work. And to release the session ID and to close the module and the communication, call logout function. So like this, we see how to implement the basic function for the Bluetooth module and how to do it using this Python script. So now this is the end just of the client side or on Bluetooth. And now Stefan will present you the next module for the Wirepas integration. Thank you.
So I will explain to you how to deploy a Wirepas microservice. So this time we will be using a Raspbian environment on a Raspberry Pi device and using a Docker container. And the client side, we will use C# this time with one of our pre-coded clients, which makes the work which makes calling the server as easy as possible. So first, there will be the video will show you how to deploy the Wirepas service using Docker. So similarly to Bluetooth, you'll get all the information on ELA websites and on ELA GitHub. So we will start by have a look at the ELA website, where you can find on the SDK page the Docker images that you'll need for deploying your Wirepas service. So here is the Docker, our Docker hub with our images that you can download to install on your Raspberry Pi. But first, we'll have a look at the GitHub of ELA Innovation and see all the different resources that you have here. So if you go to the same repository that we just had a look at, which is a ELA microservice repository, it's a pinned repository that you can find here. There is a section for Wirepas, which explains how the Wirepas network works with a Wirepas gateway and MQTT broker. MQTT broker is necessary for a Wirepas network. So here is some information on how to install one on a Raspberry Pi. It's very easy to do, and you might need one. This is some important resource. You also have some resource on how to install the Docker environment, which is absolutely necessary as well. URL here to install the Docker environment, and you also have a link to the Docker documentation on the internet, which explains everything for installing the Docker environment. Next thing is Docker Compose that we will be using. It will help coordinate the deployment of the different microservices and their references. And for this, we'll use a script. So first of all, we'll download the script and we'll copy it to the Raspberry Pi. For this, we'll connect to the machine using SSH. And so the IP of the machine is 96. I'll log in, and then we'll clone the ELA microservice repository on the machine by using git clone. On the home folder is fine. And here's the command we need to to launch. Then it's cloning in the folder, and then we'll have a look at what we got here. So first thing we need to, so you can see you have on the ELA microservices folder, you have the Docker Compose YAML. This is the script that will allow us to deploy our services. But first, we'll have a look and check that our Docker environment is up and running. So Docker info to have a look at the Docker environment. So this looks correct. Then we'll have a look and see if we have already some containers running of our application, but we have none. So we're good to go to deploy some. And we'll just check on the machine that we have the images ready to deploy, and this is the case. You will need to get them from the Docker Hub. So here we will deploy 3 microservices. First, the authentication microservice, and then Bluetooth and Wirepas microservice. And for this, we use the Docker Compose up command that takes the Docker Compose YAML and use it to deploy the microservice in the correct order and expose the correct port to be able to call them later on. But I will explain this a little bit more. So first is the authentication microservice being deployed, and because this one is necessary for the other 2. And once it's done, the other 2 can be deployed as well simultaneously because they are not dependent on each other. So we'll just wait for them to be deployed. And once they're up and running, we're actually good to go to call the server. We'll just have a look on the network and see what's going on under the hood exactly. But for you, it shouldn't make any difference for calling the application. So we're done for Bluetooth. Let's wait a bit more for Wirepas. Here we go. So we'll make sure that the the containers are running. So Docker PS to get a list of the running containers. So we have Bluetooth, Wirepas, and authentication. So the one we're looking for is Wirepas. And you can see you have the port as well, which is 552. And this is what we'll need to call the Wirepas microservice. And the last verification is the network. So Docker, when deploying the container, created internal networks so that the microservice can communicate to each other. But for an external caller, that's no difference. You just have to call the IP address of the Raspberry Pi and the port that you used for deploying the microservice Wirepas. This port can be configured in the Docker Compose YAML file. This is where you can configure the port expose. So now that we have deployed the server, we'll go on and create a client that will be able to call the API on the server from a different machine on the local network. For this, we will create a console application, a very simple one, using using Visual Studio and our pre-coded client that you can find on nugget.org. It's a public nugget, so anybody can download it. Just wait a little bit. It should come up anytime soon. Here we go. So Visual Studio will create a new project, a console application. It's the simplest of projects for .NET. For the framework, so we'll call it ELA Wirepas client because this is what it is. And for the network, for the framework, we'll use .NET 5. You can also use .NET Core 3.1. Shouldn't make any difference. First thing first is install our Nugget package with our pre-coded client. So we'll do this on the Nugget management tool and browse on the nugget.org source. And the package itself is called ELA microservice client. This one here. You will see that there are 2 of them. The second one, .NET Core, is deprecated, so don't install this one. Use the other one. You can install the latest version. There should be an agreement here, and once our Nugget package is installed, we're good to go for our clients. So first, we'll create a client object. So you'll find the client in the ELA microservice client repository under the namespace core Wirepas, single client, and then ELA Wirepas baz. This is the name of our client class. You will see here that you have access to all the API of the server, connect, disconnect, authenticate. You also have an event for data received. You can get a service status. You also have the host name and the port of the server you're connecting to. You can send the Wirepas command. You can start Wirepas data flow. So this is all the API exposed by the microservice that we just deployed. So we'll do a very quick demo of how that can work. So by connecting first to the server. So for this, we'll use the IP address of the server. Remember, it was 96. The port, remember, it was 555, but this is a constant. This is always the same. So you can find in the ELA microservice gRPC library. And the connect returns an int, an integer that you can use to do some error handling. And the significance of the integer can be found in the ELA software common library, just as shown here. So you can check if the result was okay, and if it's not, there's an error message that you can find on this library. Next, we authenticate to the service using the same login password that Mathieu used for Bluetooth microservices. It is the same authentication microservice. That's why it's the same login password. Error handling is identical. And once we are correctly authenticated to the microservice, we'll be able to call its API. In this case, we'll start a data flow. So this is some data streaming from the microservices. So we assume that we have a Wirepas network up and running and an MQTT broker that is set up on the machine 193. And this is what the microservice is going to listen to. So start Wirepas data flow, we specify the broker host name, the port of the broker as well, which is in the same library as the port for the Wirepas microservices. And once we successfully started the data flow, we'll listen for the event data received by creating a very simple event handler that will just display the data that we received from the microservice. So here we'll display the node address, the sensor data if there is some, and the battery of the node that was received, just like this. And once we've set up our data flow, we'll listen to data for 30 seconds. And after this, we'll simply stop the data flow and unauthenticate, and disconnect. So stop data flow is the same as start. You also get an integer as a result. So still the same error handling. Then we unhook the event handler. And after this, you just have to unauthenticate and disconnect with always the same method. And once we're done with this, we're able to launch our very simple console app. So first, to make sure that it compiles correctly. And this is the case, we can launch it and see the results. So here we go. First connect, then authenticate, and then we start the data flow and we wait for data. And here's one, it's a humidity temperature sensor, and you can get the battery as well at the end. Here it's an ID tag, so we don't have any sensor data, only the battery. What do we have? It's a very small Wirepas network, so we don't have much data going on. Here, two more humidity temperature sensors. And here, 30 seconds have gone by and the data flow is stopped. And we successfully disconnected from the microservices. So this is easy like this to get data from our microservices.
Okay, thank you, Stéphane. And now, just before leaving, I want to to talk about just one or two more things. The first is that all the SDK used is the same we used here at ELA. And we are packaging everything and the SDK and the Bluetooth part around a new environment, the gateway environment, to scan and connect to our device. So we will come back at the start of next year to present you what we have done with our SDK and what we are capable to do with the environment with the Bluetooth gateway environment. So stay tuned with ELA and our social media, and we will see you again maybe in the next webinar on the gateway. So to conclude, maybe Fanny say some words.
Thanks, Matthew and Stefan, for this very complete presentation. We will go to the questions, so if you want to ask them, feel free. To conclude this webinar, maybe Matthew, you can answer to the question about the evolution for the SDK. What are the evolution for the SDK and what are the next steps?
Okay, so for the moment, this is the first version, and we will complete the SDK with another functionalities, and we try to do it more interoperable for all the objects. So with the next version, you will find the same data for Bluetooth and Wirepas in our interoperable model. The one you see for the Bluetooth part in Chevron, you will have the same data with the Wirepas.
Okay, thank you, Matthew, for this answer. Maybe we can go to the next questions. Do you plan to propose samples with other languages or not?
Yes, for the moment, we just publish a sample of code with the language we use, and at ELA we are more in Python and C#, but if some customer have some trouble, or if they provide some part of code, we can help and maybe publish more samples like this.
Okay, thank you. And maybe the last questions about the price of the SDK. Is it free or not?
Yeah, everything is free directly. You can find our link related to the SDK, the sample directly on our website or in your GitHub, so you can use it directly in your project.
Thank you, Matthew and Stefan, for your presentation. Have a nice day.